So our workshop philosophy, folks, with all that said, is to do the following. Encourage you that problems are being tackled. I know it's easy to get discouraged at some of the things going on in our 21st century world. It's like, oh my gosh, we've got all these major issues confronting us. We're very empowered with tools, not just mapping tools, but statistics and science and other things in our holistic perspectives. We're very empowered, but we're also, I think, sensing that we're very challenged in many ways that maybe we weren't thinking about 20 years ago. But problems are being tackled with mapping technologies and the spatial perspective, and also empower you with some skills to create your own maps. Hey, Joseph, how do I do what you just did 15 minutes ago? How do I make my own maps? And also, this is your workshop, as I indicated earlier. Please ask questions and interrupt me, and like Leslie did, thanks, Leslie, to enhance the learning. That's what I'm here for. And I love learning along the same lines as you do. I'm always discovering new things when I'm teaching one of these workshops and courses. So glad to be with you today. Here's another thing that I just wanted to mention as well as we go forward, and that is when you think about all those challenges that we mentioned earlier, they're all spatial. They all have a geographic imprint. They have relationships with other phenomenon on our planet. They don't occur in a vacuum, right? Hazards are associated with population, and they're associated with, okay, what's happening with sea level change, et cetera. And they occur over specific scales, map scales, and over time periods. So there are a temporal and a spatial component with all of these. And mapping technologies, geotechnologies, are sort of like an elevator. They're operating behind the scenes. You know, you get in an elevator, you push buttons, and you expect stuff to happen. With mapping technologies, they're operating to enable our modern world. So the power that is powering your computer right now, you know, Excel Energy uses geographic information systems to figure out where all the electrical lines, the gas lines, the power stations, all of it are located, and how and what the electrical grid is functioning or not functioning at the moment. Okay, so they are what you had to eat today or yesterday. Supply chain management. How did that food get grown, distributed, transported, and eventually wind its way into your own house? All that supply chain management stuff, and as we've seen in the last few years, sometimes that supply chain can break down or dysfunction in some ways. But that's all run with geotechnologies. It's not just, I mean, imagine UPS or FedEx having a bunch of paper maps on the wall saying, well, we've got 4 million packages to deliver today, and we've got 200,000 trucks. They're not going to do that with a paper map and a bunch of spreadsheets. They're going to do it with geographic information systems. All that logistical stuff is run with these tools. And ditto for hazards, not just hurricanes as we examined today, but wildfires, tornadoes, floods, etc. So everything that really you encounter in your everyday world is enabled in part through these geographic information systems technologies. Now, one of the things that we are anchored in today and next week is space and place. One of the things that I love as a geographer is that these are real world spaces. They're not just theoretical. And so, you know, I have these interesting discussions with my mathematics colleagues that there's a lot of mathematics in mapping, but some of the things that the mathematics colleagues of mine grapple with, and maybe you all grappled with in your present or past careers, is they're theoretical constructs. They're not really real places or real issues, but you're modeling something in your world. But mapping is always tied to something real. And even if that real thing is on an extremely local level, i.e., there's a lot of work being done on mapping the brain, the human brain right now, and internal organs. So extremely local. It doesn't get more personal than that. On to global hurricane patterns and everything in between. This is a photo that I took at the border of Colorado and another state. See if you could put your geographic brains on. This is a bit tricky, but I know you folks are the Academy for Lifelong Learning, high intensity lifelong learners. So you can think about, where might that be? It's on the border between Colorado and another state. It doesn't look like Colorado and Kansas, right? No, I don't see those kind of mesas on the Colorado-Kansas border. I've been to Colorado, you've been to Colorado, you've been east of Los Animas and on into Kansas perhaps. That doesn't look like the Kansas-Colorado border. So that's just one hint. It's not that one. What one is it? Colorado, and you're thinking about what are all those states that border Colorado and where did Joseph take that photo? It's a bit, it's not maybe one that you're gonna think about right away perhaps. It's not at the Four Corners, but that's a good hypothesis. You've got those. There's some cholla there. There's some buttes. There's some cuestas. There's some mesas. But it's not the Four Corners. So it's not any of those states at the Four Corners.
Utah. No.
No, it's not any of the Four Corners states.
Yeah.
Arizona.
All right.
Texas.
Wyoming.
And it's not Wyoming. So you're narrowing it down now. You've got two left. Well, actually, yeah, you've got two left. We ruled out all the Four Corners states, and we ruled out Wyoming, and we ruled out Kansas because of my hint. Now you've got two remaining.
Texas and Oklahoma.
Oklahoma. It's the Colorado-Oklahoma border. It's right there at Black Mesa, Oklahoma, which runs right along 37 degrees north latitude. So that's where I took that photo. And I love being on state lines. I just, as a geographer, I love borders. And here's another place that's interesting. This is the highest point in a certain state. It's obviously not Colorado because it was pretty easy to walk there, as you can see. It's pretty flat. What state is it the high point of? There's a little clue in that sculpture that's over to my right hand there. That one gives you a big clue as to what state it might be, the high point of. It is Mount Sunflower, Kansas. The local rancher, I think perhaps got tired of people wanting to go there, so actually the local rancher set aside this little, it's a little bit windblown, but it's a couple of logs, as you can see, a fence and a little sculpture there. But that's Mount Sunflower. It is over 4,000 feet, and it's in Kansas, just barely over 4,000 feet in elevation. But that was me on a very hot, windy day, which probably is most of the days there, except for in the winter, of course. But it's probably always windy there. But speaking of that, I've got. Okay, recognize this place? See more of these points on a map. So I'm going to click on that link, and this is again in that last sway.office.com link that I shared in the chat box. But if I go to that map, I'm going to go to this map right here, which is a map I built based on state high points, the highest point in every state. And you can see the elevation I've symbolized with a blue and with low elevations and reddish for higher elevations. So this one right here, of course, is the one we just looked at right on the Kansas-Colorado border, but in Kansas, so it is the highest point in Kansas, 4,039 feet above sea level. You can see, if we zoom in there, you can see how close it is actually to the Colorado border. It is really pretty close to the Colorado border. Gosh, if only we had a measure tool. Look, we do. We have a measure tool, and here it is. So now I could say, ooh, click on the Colorado border and go over there to Mount Sunflower, and it's less than a mile, 0.59 miles to Mount Sunflower from the Colorado border. Interesting. So the interesting thing is that with all maps, you're starting to see patterns, relationships, and trends. So if we look at this map right here, you can see that all the Great Plains states, look, the highest point is actually really close to the western border of those states because, you have this vision of, okay, well, it's going to slope gradually down to the east, and you're exactly right. So there's the highest point in North Dakota, right, which is White Butte, 3,500 feet. And then South Dakota, not too far from the Black Hills, or really in the Black Hills, actually Harney Peaks, that's higher because it's in the Black Hills. And then this one in Nebraska is really close to the Colorado, Wyoming, Nebraska tri-point, which is an interesting place because it's the intersection of three states. But right here is 5,400, pretty close to Cheyenne, actually, just east of Cheyenne. And then there's Mount Sunflower, and then there's this place that I was close to, Black Mesa, that I was talking about in Oklahoma. But fascinating to look at these patterns and say, wow, I really hadn't thought about where's the highest point in Iowa, for example. I was there back in August. It's called Hawkeye Point, which is suitable for Iowa, right? But you can see that it's okay for Iowa. It's it's almost 2,000 feet high. But makes sense that it's in the northwest part of the state rather than in the lower part of the state, which is over by the Mississippi River. But fascinating to look at this. Also, no surprise to you all, the high point in Minnesota is up in the Mesabi Range, right? It's up in the iron ore range and close to, but not too far from the Canadian border and Lake Superior. The highest point in Michigan, right, is actually the UP. Don't you know? Up in the Upers, up in the Michigan there. And it's not in the lower part of the mitten, right? So it's up in the mountains of Michigan. But fascinating just to look at this and see what the patterns are, and of course the elevations themselves being, of course, higher over here in the west versus over in the east. But you've got some fairly high elevations in the Appalachians too. Another interesting thing about geographic information systems is they're all tied to real-world spaces. So unlike some paper maps where, Alaska and Hawaii are situated south of Arizona just to fit them on the paper map, right? You've all seen those kind of maps. Alaska and Hawaii are actually in their correct geographic position. So I've got to scroll southwest of California to get out to Hawaii. And of course, as you know, you've got Mauna Kea there. And then up in Alaska, you folks know what it is. It's due north here, Mount McKinley / Denali up in Alaska. So the point is, okay, wouldn't it be interesting to change that base map like we did before to something that allows us to understand things a little bit better? I've made it a gray tone in the back so you can really see the elevations pop out. But you're probably thinking, yeah, Joseph, show me the terrain with labels. So now it makes sense that this mountain is up here in the Alaska range. And then if I scroll down to the lower 48, right now, maybe I've got a better sense of, okay, well, now I get it a little bit better because, for example, the Black Hills, okay, that's starting to stand out here on this map. Fascinating. Okay, very good. So we're all anchored in space and place, and that's important to mapping as well. Now, geography is really the fundamental science of mapping. Geography is not this. So geography isn't just memorizing capitals. No. That's oftentimes what I get. Hey, Joseph, I had geography in 7th grade, when we memorized the imports and exports of Peru or the capital of Venezuela or Zimbabwe. Those are facts, and facts are important to any discipline, but that's not the essence of geography. It's also not what Miss South Carolina said, with all due respect to Miss South Carolina, but it was basically the answer that she gave to one of those questions was, hey, why do we have this dearth of geographic knowledge in our country? And her response was that there are not as many maps as there should be. Again, cutting her some slack because she was on the spot and so on, but it's a rather famous interview. But the point is, we have more maps than ever in our society. The lack of geographic literacy goes much deeper than how many maps we have. It's what do we value in our educational systems? What do we teach? What do we not teach? More about that in a bit. But geography shouldn't be this either. It shouldn't be the most boring thing ever. These students half asleep, right? It's actually quite exciting. It's actually quite revolutionary, as we'll talk about, and it's the fundamental science behind mapping. Although, as I journey down there with you for the next few moments, realize that people from literally A to Z, architecture, anthropology, to zoology, and every discipline in between, use geographic data and do this kind of geographic information analysis. It's not just geographers. So actually, though, circling back to geography, it's actually quite revolutionary. This is a picture I took at our ESRI, Environmental Systems Research Institute headquarters in Redlands, California. We have an office here in Colorado in Louisville, where I work out of, but this is our office in Redlands, and we have as you can see, a big geography wall. We have to keep that trimmed so people can see it. But the point is, that is the fundamental basis for mapping is geographic science, geographic sciences. And geography really is, as the word, if you break up the word, is geo, meaning earth, and graph, the Greek, to describe or to write about. So describing the earth, geography. I've got a video that I won't bore you with right now, but I've got a video channel that is called Our Earth. And the Our Earth channel, and I've got to skip through this ad, sorry. My Our Earth channel has 5,000 videos, okay, on this channel, Our Earth. So I encourage you to check it out if you want to learn more about all this. Some of them are a little bit geeky. I know many of you are very passionate. You're probably all very passionate about your own profession, and I'd love to hear more about what your backgrounds are here in a bit as we go toward the break. But I'm going to put the URL for the Our Earth channel in the chat box so that you can explore some of these. You can see there's a wide variety of things in there: latitude, longitudes, geographic information systems, education, science, technology, engineering, and math. There are lots of things on that channel. I'm very passionate about all this. So let's talk about the core questions in geography. What's where? Okay, is one of them. What's where? Okay, so here's a photograph. I want you to think about, where did Joseph take this photograph? Interesting. Do I recognize any of those place names? What's where? Why is it there? Okay, so same city, here. What city am I? Where am I taking this? And then why should we care? What's where? Why is it there? And why should we care? Those are the three fundamental questions to what we're talking about today with our Mapping Our World course. What's where? Why is it there? And why should we care? Okay, so you're thinking geographically. You're thinking about, I've got this needle, and I've got an estuary, and someone was on the Seattle track, which is the right ocean, but it's not the right city. So keep thinking, and you're thinking about, okay, what is a little bit of a place name clue with two of these four actually all four of them have something to do with the history of this particular country. And so I'm thinking, what's where, why is it there, and why should we care? Interesting, fascinating to be able to do this, to ask and grapple with these three questions. Any guesses? Any further guesses?
Vancouver?
You're still on the right track on the ocean.
Is that near the Puget Sound?
No. But again, I like what you're thinking about. You're thinking about, okay, body of water. I've got some interesting sort of marine influenced vegetation there. Here's another clue. I'm actually standing on one of the many cinder cones, volcanic cones that dot the city. And they're all most of them are set aside as parks. So they make nice hiking trails and wonderful vistas of the city as you're walking around it. Here's another clue. This may be difficult to determine here, but notice that they're exiting on the left side of the highway. The ramp is off to the left rather than to the right.
Are you in the Southern Hemisphere, Joseph?
Yes.
Are you in New Zealand?
Good on you, mate. Yep,
Okay.
we're in New Zealand. This is Auckland. So you've got those volcanic cones, you've got the needle there in Auckland, and you've got some English influenced names, and you've also got the Maori influenced place names in the same country. Fascinating. So what's where, why is it there, and why should we care? So a lot of times when I'm working with students, it's like, okay, well, so what about hurricanes? So what about wildfires or population change or habitat loss or climate or sea level rise or whatever? Why do we care about all that? Because we care about the planet and its people. So it's actually quite relevant to our 21st century world. Geography then is about space, patterns, relationships, and trends. Is there any relationship between this variable and human health, like we talked about? Is this variable and we looked at pressure earlier, wind speed, they're related, and this hurricane, okay? They're all related, interrelated. Also, geography is about time. This particular graph, it's not a map, but it's kind of intriguing because the graph shows different population changes over the years in some of the USA's largest cities. So this pinkish area is, from 1790, the time of the first census, and I used to work at the Census Bureau. I love census data, population data. Maybe you do as well. Up to 2010, you can see the sort of rise of New York City, especially right around the early 20th century. And then you can see, okay, this is Chicago, being fairly prominent in the late 19th century, and then, dropped from number 1 to 2 because of this startup, this burnt orange color, Los Angeles, surging up there in the mid 20th century. And then you can see some interesting patterns where you've got a lot of these Texas cities, Dallas and Houston, surging up in the mid 20th century. And then that relative decline in terms of the ranking of places like Philadelphia and Boston. So it's fascinating to look at things over time as well as over space. And they're really intertwined, geography and history. All historical events occur somewhere, and all geographic events have a temporal component to them. So that's one of my favorite maps. We'll talk more about those in a bit. But as I mentioned before, geography is all about systems thinking. It's really about looking at the world holistically and interconnected, not just in these spheres, but also in cycles. the hydrologic cycle, the carbon cycle, and other cycles. So the interesting thing now too is that with, as I mentioned earlier, with geographic information systems, we can visualize things in new ways. So this is traffic accidents. We've basically made hexagons in certain places, in intersections in a county. This is a county in coastal Florida on the Atlantic coast, and then extruded those above the surface. And then we ran a spatial statistics algorithm across that data. And so just like projects you've worked on in the past or at present, you've got a limited staff, budget, and time, right? There's always some constraints. So in this case, if I said, okay, I'm going to address traffic accidents in my county, but I only have a certain number of hours and staff time and resources, I'm going to focus on these ones that are consistently with a 99% confidence level that there's consistently high accidents in those areas. I know there's accidents in other places, but they're not statistically significant, consistent hotspots. So I'm going to focus on those. And that's where, the element of, we really are trying to make a safer, more resilient world. That's where these mapping tools can really help. So we're kind of visualizing things in new ways so that people can make smarter decisions is the whole idea. Spatial patterns and uncovering relationships. And I really like this whole idea here because I hope I illustrated it a little bit anyway in the intro mapping activity where we were looking at the hurricane situation. But we're asking questions, we're gathering some data, we're analyzing it, mapping it oftentimes, we're acting on the geographic knowledge and maybe encouraging other people to take action about accidents or about litter or about water quality or some other issue that we really care about, or open space trails like we talked about before we actually started the formal session today about the protection of open space in Arapahoe and Douglas counties, Colorado, for example. And that leads to additional questions. The cycle keeps going, and that's what I love about this whole inquiry process. And then lastly, in terms of this section of the course, these are the founders of my organization, Jack and Laura Dangermond. They, back in 1969, started this environmental consulting company, Environmental Systems Research Institute. And for the first 10 years or so, we basically, if people wanted to report on that mine site or that watershed or that proposed open space, we would analyze it, submit an environmental report to them and deliver it to them. And they said, these graphs and maps that you have in this report are really intriguing. I want to do that too. How can I do what the results of the report are showing me? In other words, the people that we were delivering those reports to wanted to be empowered to do it themselves. They wanted to be empowered to create their own analysis for not just that problem, but other problems and issues. So that's when we became a software company who said, okay, we're going to provide the tools that people can then use to make their own to do their own analysis. We still have a professional services division where we provide that kind of service to people, but the main task that we have is actually to provide tools like those tools that we were looking at the hurricanes with so that people can make smarter decisions. Anyway, another nice story about Jack and Laura is the elbow of California. Gosh, if only we had a map at our fingertips. Oh, look, we do. We have the state high points. If I go out to the elbow of California, this elbow out here, if I zoom in, and wow, some of you have been down here, but down around Lompoc and some beautiful terrain there. If I change that to a topographic base map, okay, so I've got, the elbow of California. Look at here, the Jack and Laura Dangermond Preserve. That whole big chunk of land, our founders bought and donated it to the Nature Conservancy. I just share that because I want people to know that, especially when I'm conducting career presentations with students and think about, hey, what kind of organization do you want to work for? In our case, our founders are practicing what they're preaching. In other words, they're not just saying, we all need to protect the environment and, think holistically, et cetera, but they're actually living what they're talking about. So this was the biggest donation that the Nature Conservancy had ever received. It was something like $200 million for that big piece of land. And so the point is, it's going to be open to the public. There's trails and things like that, but also open to research. The main thing, though, is that it's never going to be paved over with a bunch of condos. And there's like 300-year-old oak trees out there. There's some cougars. There's some awesome birds. And so I just like to share that because, wow, that's a pretty, you don't want your CEOs to be jetting around partying. You want them to be doing what all the employees are doing, and that is promoting wise stewardship of the land. So I like that story, and I just wanted to share it with you all. Yeah, questions, comments?